Okay, good afternoon. So, today I do not want to teach a new lesson, but I just want to solve some problems for you. And I think it would be better if I write the problems first here, so that you can work on them yourself, and then I will come back and try to solve them. Okay? The levels are a little bit harder than the one expected in the book, but I think you can solve it yourself. Okay? So I start with a very simple one to refresh your memory a little bit. So number one, so you can start solving them. As soon as you see the first one, don't waste your time, just start solving them. Show that
no equation.
okay, so I want you to solve these problems. I try to order them in the level of difficulty. So I think I give you around 25 minutes or so, and then we come back and try to solve the problem.
The general solution satisfies the equation and should contain as many free parameters as the order of the equation. Frågan är vilka här är general solution.
Sex.
Okay, did you finish everything?
Oj, nej. No. But I don't think we will ever finish.
Why? Ever? Ever is a long time, isn't it? Okay, but let us start doing it. The first one is very simple, and I think it's very close to the problems in the book. Yes, so we are supposed to show that that function up there is a solution to this one, and I think I have asked you a trivial question. I want you to know the difference between the general solution and, I don't know, in this one, a particular solution. These are the terminologies that are used in this context. I just want you to know about it. So I want to show that this is a solution to this differential equation. So it means that when I replace y with this given function, this should be equal to 0 identically, no matter what x is. That's the meaning of being a solution. And if you see, I have the first derivative of y and the second derivative of y, so it motivates me to calculate the first derivative, which is 2 plus 6x, yes? And then y double prime is very simple, 6, yes? So I start from the left-hand side. Instead of x squared minus 1, I just write x squared minus 1, and then multiply it by y double prime, which is 6, minus 2x times the y prime, and then I have plus 2y. 2 times y, which is 2x, plus 3x squared plus 3. So I have just calculated y prime and y double prime, and I have substitute these two for y and y double prime, and I hope that if I simplify that, it becomes 0 identically. Yes? So this means that I multiply 6 in, then it becomes minus 4x minus 12x squared, then you get 4x plus 6x squared plus 6. And then hopefully you see that 6x squared, another 6x squared, 12x squared, and this is negative. So they are cancelled. And this one and that one are also cancelled. And this one and that one are also cancelled. So the answer becomes identically 0, and 0 is the right-hand side. So you see the left-hand side is equal to the right-hand side, independent from the choice that I make for x. For every value of x, this is correct. But can I call this the general solution of this differential equation? Can I call it the general solution? What was the feature in the general solution? Yes?
That it has as many free parameters as the order.
The order, exactly. So what is the order of this differential equation? The highest derivative that appears is second order. So this is a second order differential equation. But how many free parameters I expect for the general solution? 2 free parameters. But how many free parameters are introduced? Nothing. Yes? There are no free parameters in the solution that is given, so that is not the general solution, it is a particular solution if you want to call it. Yes? So that's it. So the next one, the idea is exactly the same, but the function is more complicated, so you need to practice in differentiation, that's it. And the other thing is that x plays the role of y, t plays the role of x. So that's x is a function of time, that's it. And then you see that this is the Leibniz notation, which is very common in differential equations rather than this one. So you see, if I haven't written this t here and I have just written x double prime, then it becomes a little bit strange because you might say that x double prime is 0 because x prime is 1, x double prime is 0. But when I write it in that form, it tells you that x is a function of t. So do not consider dx dt as x prime. It's just a derivative of the function. Okay, so number 2. I have to do a little bit of calculations here. So you see that I have the first derivative and the second derivative. So from that equation, I calculate the first derivative of x with respect to time. Okay, here I have a product rule. Here I also have a product rule. So what I have to do, I have to use 2 product rules. So I write A. This becomes the derivative of this one multiplied by the second one itself. So it becomes minus e to the power of minus t multiplied by the second one plus the first one multiplied by the derivative of the second one, which is cosine t. This expression is actually the derivative of the first one. I do the same thing for the second part. So this becomes b. The derivative of e to the power of minus t is this one multiplied by the second function, but plus the derivative of cosine becomes negative sine, so it becomes again negative sine t. So this is your first derivative. But then you have to be a little bit careful for the second derivative. Can I simplify this a little bit more? If you want, let us simplify it a little bit, but let us do it in our head, yes? So you see, if I multiply, but let me multiply. So it becomes minus a e to the power of minus t sine t plus a e to the power of minus t cosine t minus b e to the power of minus t cosine t minus b e to the power of minus t sine t. Yes? I think you agree with me that's a good idea if I factor here and if I factor here, yes? So what can I factor here? I can pull this expression out. A is left from here, minus b is left from there. Yes? And between these two, I factor a negative sign, and I also factor this expression, but from the right-hand side. Yes? And then what is left here is a plus b. Okay, let us wait and see if you understand what is going on. Is that understand what I have done? Yes? Let me double check myself. So between these two, I factor this out. Between these two, I factor the minus sign out, so it becomes positive and positive, and I pull this one from the right-hand side. So that's correct. Yes? Oh, but this is the first derivative. I need one more, yes? I need taking derivative once more, but the idea becomes very clear now. So the second derivative becomes again the product rule here, the product rule here. So it becomes a minus b, and if I differentiate this according to the rule, it becomes this. That is the derivative of this one using the product rule, and the same story for the other one, yes? So what is happening? Minus e to the power of minus t sine t. Yes? So that is the second derivative. Okay, so it is a little bit annoying, but so I multiply this one here. If you don't mind, let me just write minus a minus b and e to the power of minus t cosine t. I multiply this in. And then I multiply that one in, it becomes positive. And the next one becomes negative. Yeah, so that is just multiplication. And let me just do the same idea once more. You see here, again, disappears. And I also have one here. Okay, can you do it in your head? You see, if I multiply this minus sign here, it becomes positive b. But if I multiply this minus sign here, that becomes negative b. They are cancelled. And then if I get minus a here, there is another minus a here, so it becomes minus 2a. Yes? And what about here? If I multiply this minus, it becomes minus a, positive a. So it is gone. And this becomes positive b, it becomes positive 2b. I hope that I haven't done any mistakes. So then this is the second derivative of x. Yes? Can you confirm my calculation or not? So have you already done that? Are these the things that I got are the same that you got? No? I hope that I haven't done mistakes, you know. But anyway, let us see. I start from the left-hand side. It is the second derivative, so let us copy and paste this one. Yes? And then I have 2 times this first derivative, so I have to multiply this by 2. And when I multiply this by 2, if you don't mind, I also multiply these things in, okay? So it becomes plus 2 a e to the power of minus t cosine t minus 2b e to the power of minus t cosine t. So I multiply this in, and then I also multiply the 2. And I will do the same thing here. So it becomes minus 2a e to the power of minus 2 minus t sine t minus 2b e to the power of minus t sine t. Yes? And then I have 2x at the end. But x is this guy. And I multiply it by 2 and add it there. So if I multiply it by 2, yes? Okay, so at least I see this one and that one are gone. This one, 2be minus t sine t. Yes, this one with this last one are gone. 2a minus t sine t with this one, they are cancelled. And finally this one with that one are cancelled. And that is 0. And that's equal to the brackets. Yes? So it was just the same thing, but you have to be careful in differentiating and doing the algebra right. Yes? Okay, but I want you to also know this terminology. This is why I'm using all the phrases here in these problems. Using this, I mean using this solve the following initial value problem. What do I mean by initial value problem? I mean a differential equation together with some extra conditions that you have to make the solution be satisfied. Yes. So if you see this equation that I have written here is exactly this equation, but I'm using the prime notation for the derivative here. And then I have given you two extra conditions. Because this is a second order, I have to give you two extra conditions. Okay, and that is easy, yes? What you need to do, you already know all the solutions. That is the general solution for this. But you need to fine-tune these parameters A and B. By the way, in the exam that is not enough. You have to add one English sentence. Because I have mentioned to show that this is the general solution. So after this part is finished, you have to show, you should tell me that this is the answer because of this calculation. On the other hand, there are two free parameters in this solution, and the order of the differential equation is 2, so this is indeed the general solution. So this phrase you have to add at the end to show that this is the general solution, but I am lazy to write it down, I just told it. Okay? So, I will go here and do this calculation. So what should I do? The function at 0 should be equal to 1. What does it mean? It means that if you go to your function, replace t everywhere with 0, the answer is supposed to be 1. So, okay. The next part of the problem, x of 0 is 1. So this gives me, if instead of t I put 0, sine 0 is 0. So this is totally gone. And then this becomes b. E to power minus 0 is 1. Cosine of 0 is also 1. So the left-hand side becomes b. The right-hand side is supposed to be 1. So I got b. Yes, that is this condition. I use this condition. But there is another condition for the first derivative. The first derivative at 0 should be also equal to 1. So I need to go here. This is my first derivative, you see. I need to replace t with 0. The answer is supposed to be 1 again. So x prime of 0 is given to be 1. It means that I replace t with 0. If I replace t with 0, sine of 0 is 0. So the whole expression is gone. Cosine 0 is 1, e to power 0 is 1, it becomes a minus b. Okay? But I already know that b is 1. So I put it here. So this means that a is 2. Okay, but what you have to write as the answer, you have to start writing it all over again. X of t is equal. Instead of a in that equation, you put 2. And in the other equation, instead of b, you put 1. Yes? And yes. I prefer to factor it out. It doesn't matter, of course. So that is the initial value. The solution to the initial value problem is this. Yes? Okay, so this I think is a little bit tricky, I remember. When I was solving it myself, I did a mistake in my calculation, so I have to redo it again. But I don't know how many of you could do this one. That is the same problem here, but this was a very simple function. This is a little bit more complicated function, but the idea is exactly the same. Okay, so we can do it together. Okay, I don't know how many of you succeeded to solve that one. Did you reach to that to try or not? The time was not enough.
We started.
Okay, so I will give you a little bit more time because we have a little bit of time and 2 more problems. So I will again give you time. Yeah, this is, I remember, it is a little bit tricky. Make sure that every step that you are following is actually very firm and rigid before going to the next step, because the calculation is a little bit long. And I don't want you to miss it. But the number 4 is interesting. So there is some idea you need to discover. Because here I have given you a function with 2 parameters, I am asking you, can you find a differential equation whose general solution is this? Of course, this is just a mathematical curiosity, yes? Not it's more than that, because sometimes we really need to write a differential equation for a family of curves. This I call it a family of curves because if I change a and b to different numbers, I will have different curves. Yes? Okay, I will give you a little bit of time to think about at least number 3. Okay, I think might be we will not have time to complete this, but let us think about this problem. What do you think about? For example, if I talk about numbers, if I give me a simple equation whose solution is 2, this is very simple for you, yes? What is the equation that you tell me? Give me an equation whose answer is x equal to 2, just a normal equation. The simplest possible one.
X plus 1 is equal to 3.
Yes, even simpler, x minus 2 is equal to 0. Yes, you're right. Now if I give you, for example, this equation, this problem, by the way, can you do it for me? Give me a second. Okay, give me a polynomial equation with integer coefficients so that this is a solution. So a polynomial equation with integer coefficients so that this is definitely a solution. You need to find a systematic way of finding it. It is not that easy as before. I expect you should be able to give me that polynomial equation. Let me ask you a simple question to guide you. Give me a polynomial equation whose solution is this one. If I give you this, you might say x minus the square root of 2 is equal to 0, and I agree with that. That's an equation whose solution is this. But now if I tell you, give me an equation, a polynomial equation with integer coefficients, then you cannot refer to this, because the coefficients are not integer. One of them is the square root of 2. Can you tell me an equation with integer coefficients that this is a solution to that? What is that? Just say to me, it's very simple. Give me an equation with integer coefficients whose solution is the square root of 2. What is that?
X to the power of 2.
X to the power of 2 minus 2 is 0. Yes? X to the power of 2 minus 2 is equal to 0. A square root of 2 is a solution of this equation. This is a polynomial, and the coefficients are 1 and minus 2, that they are integers. And now I'm asking you the same question for a little bit harder problem. I want you to find a polynomial equation for which this is a solution and the coefficients are all integers. It is not easy to guess, but if you do it systematically, you can find that equation very easily. Any idea how to do it at least? Where are the answers? Okay, can you tell me what to do? For this simple problem, it seems a little bit unrelated to what I'm saying, But yeah, you can find a connection somehow. So how can I find this? So I would say that x equals to a square root of 2 plus square root of 3. I raise both sides to power 2. It becomes 2 plus the square root of 3. Yes? And then I move 2 to the other side. And then I square it once more. Yes? And then I raise it to power 2. X to the 4, 2 times the first one times the second one. This one to power 2 is 4 minus 3 is 1. So that is your equation. But you couldn't guess it. If you can solve this equation, there might be other solutions, but this is guaranteed that this is indeed a solution. Yes? Is that clear? So this is a polynomial equation whose solution is this one. Now this problem is much harder because I want to find a differential equation, and the problem is that, but at some point, if I ask you to solve this equation, in principle, if you remember from Math 2C, you should be able to solve it as well. But here, your knowledge about solving differential equation is completely limited. So in principle, you need to find an equation so that if you give that equation to someone who knows how to solve the equation, and that person solves the equation, he or she will get this answer. Yes? Okay, tell me.
Y prime prime minus b times y prime.
So y prime prime?
Yeah.
Yes?
Yes. Minus b times y prime equals to 0.
This is not acceptable.
Okay.
Why? Because that is the meaning of the general solution. You see, A and B are going to play the role of the free parameters of my solution. Might be I am a little bit sloppy in my language, but that phrase that I have mentioned, I have written A and B are arbitrary constants. Yes? So it means that the arbitrary constants are not already there in your equation. Arbitrary constants are constants. Yes?
Okay.
Do you understand what I mean? The B that you have put here will give exactly that B.
Yeah.
If I change it, if this is 5, then the answer to that will be 5 here.
Yes.
But I want to find a differential equation which doesn't have A and B in it, but if you solve it, it will give you two constants A and B.
Okay.
I don't know if you have done it right, but I think you have done it right. But I mean that this is not my answer. Is that understandable? I want an equation independent of the free parameters. You see, in this problem, if I ask you to solve this differential equation, you do not see capital A and capital B in this equation. But if you solve it, you will get it.
Yeah.
Yes? That's the point. So it's a little bit harder than that. But do you have a strategy for that, Diman? Might be your strategy is correct.
So I take the first and second derivative
Why do you stop up to second derivative?
because there's
Two free parameters, and I want to make the general solution. So if that is going to work, that differential equation should be of order 2. So it means that at most I need 2 derivatives. Okay? So that's a good starting point, by the way. So I take the derivative. What happens? It becomes A, B goes down, and the function repeats itself. Yes? That's it. And then I take another derivative. What happens? Another derivative B goes down, so it becomes AB squared e to the power of bx. First derivative, second derivative. Okay. So you were very close. Can you solve it yourself now? Because the equation that you gave to me, what was that? Y double prime minus b y prime equals to 0. And that is correct. Because if you multiply this by b, it becomes ab squared e to the power of bx. And then you subtract them, it becomes 0. So that's correct. But that was the problem with your solution. But can you fix it now? So, in other words, you want to write a differential equation for which it holds and is independent of the parameters a and b.
maybe if you square
Mm-hmm.
y prime divided by
No, if a square is not good, because when you square, you will actually get, this becomes 2.
Yeah.
But your idea is completely right. I understand what you mean. It's better to divide.
Yeah.
Because if you divide, you get rid of most of the things, yes? So if I divide y double prime by y prime, what will happen? This becomes ab squared e to the power of bx divided by ab e to the power of bx. And then this one and that one are gone, this one and that one are gone. What is left for me is b. So what I get is exactly what you told me here. So that is y double prime over y prime is b. Okay? Then can you tell me what to do now? The strategy is clear. The strategy is to get rid of a and b.
You can take that minus.
You can put it back into one of these equations and find a. Yes? So you put this back into the simple equation. This becomes y prime is equal to, instead of a I just write a, but instead of b I put this complicated relation. And then I have e to the power of, again, this relation times x. Agree or not? And then I am looking, don't let these things distract you. Your goal is clear. Your goal is to find a for any price you want, actually. You are ready to pay any price here, yes, to find a. And then you could find it, yes? What is a? Can you tell me, is a is equal to this one multiplied by that one, and then divided by that one, and divided by that one. But instead of dividing, I bring it up and make it negative. And that is your a. Yes? And what is the last step? Where is my differential equation? I haven't found the differential equation yet. I found b. I put it back into this equation. I found a in terms of x, y prime, and y double prime. But where is my equation now? Can you finalize the problem? One more step, you are done. So what can I do now? You lost the logic.
Yes.
Yes? When I ask you to write a differential equation, I mean to find the relation between x, y, y prime, y double prime at most. So this is why, this is a very strange way of doing things, but that is possible because I am looking for a and b. I got them, and then I put them back into this equation, then I am done. Yes? So y becomes equal to, instead of a, I put this complicated expression. This is instead of a, and e to the power of, instead of b, I put this expression. Am I right? But something interesting happens. Whatever this is cancelled, and that's your differential equation. Y equals to y prime squared divided by y double prime. And then you multiply, so this is your nice equation. Okay? So if you give me this, I think I can solve it. Because the reason I say I think, because usually this is not the case that if you give me any differential equation, I can solve it. Not only me, but it's not possible to solve all differential equations. But in this case, I think it is possible. Okay, but one thing is clear for you. If someone solves this differential equation, you know the correct answer. The correct answer should be that. Is that clear? So I would consider this a hard problem because the way that you have to think is different. This is, I don't know if you call it a hard problem. This is a lengthy problem, but you have to be very good in differentiation of function 2 times using the chain rule. Okay? And then plug them here, and then be good in algebra so that you can generate a solution. Yes? But in principle, I really love these kinds of calculations, yes. So because that's kind of a challenge, yes. You want to say that yes, I could do it, and I hope that you have the same feeling. If you don't have that same feeling, you will not learn mathematics. Okay. So I don't know. You couldn't. You shouldn't be able to sleep tonight before finishing this. If you don't have that attitude, probably you shouldn't be a mathematician, yes? Okay, so I will actually pause recording a video. If you want, you can think about it. If you have questions, you can ask me. But I really recommend you to be able to finalize that problem. It's nothing except differentiation. Thank you very much.